Page 9 of differentiation rules. So we're continuing here with log derivatives. So we're going to find the derivative for log of 1 over x. So this is a function inside of a function. The outside function is natural log, so we're going to do 1 over the inside function. And then we're going to take the derivative of the inside function. So the inside function, I'm going to rewrite it as x to the negative 1. The derivative of the inside function would be negative 1 x to the negative 2. So it would be negative 1 over x squared. So this would be multiplied times what we already have. Okay, and now we're going to do some fraction simplification. So 1 over x is actually just equal to x. And then I have negative 1 over x squared. So the x cancels with the x squared on the bottom, and I get negative 1 over x. Okay. Remember, natural log of 1 over x is the same thing as natural log of x to the negative 1. So we could rewrite this as negative 1 natural log of x. And now you can kind of see why it ends up being negative 1 over x. Okay, y equals 1 over the natural log of x. So in this case, I could rewrite this as natural log of x to the negative 1. And this is a little bit different than this, right? Because this negative 1 is just on the inside and this negative 1 is on the outside. So the outside function is to the negative 1. So when I take the derivative of the outside function, I bring down the negative 1, I leave the inside the same, and I lower the exponent by 1. Then I need to do chain rule and take the derivative of the inside. Derivative of natural log of x is 1 over x. Let's try to simplify this. So it would be negative 1 over natural log of x on the bottom times x. Okay. Number 3, use the log laws to help differentiate with respect to x. So here, let's rewrite this as natural log of 1 minus 2x to the 1/2. So we could use the exponent rule for logs to put the 1/2 in front. That makes it a little easier, doesn't it? So now when we take the derivative of it, we just leave the 1/2 in front, and then we take the derivative of the inside. And then the chain rule, we would put negative 2 on top. Remember, chain rule, you're always multiplying on top by the chain rule result. So I could cancel out the 2's, and I would end up with negative 1 over 1 minus 2x. Okay. So let's see, natural log of e to the x times square root of x. So here I have a function inside of a function. I can make this a little easier if I use the log rules. Remember, natural log of a product is equal to the natural log of the two factors with the natural log separately. Now, let's see, the natural log of e to the x, this cancels out, it becomes x. Natural log of square root of x, let me rewrite that. I'm going to rewrite it as natural log of x to the 1/2. And then I'm going to rewrite that as 1/2 natural log of x. So the derivative of this would be 1/2 times 1 over x. So it would have x plus 1/2 of 1 over x. So it would be x plus 1 over 2x. When did I actually take the derivative? I actually took the derivative here, right? Here I was just rewriting. Here I was just rewriting. Okay. Now I'm going to do the natural log of a quotient. I can simplify this first by breaking it into the natural log of the numerator minus the natural log of the denominator. That's a log rule. Then I can do the derivative of each one separately. So this would be 1 over x plus 3, and this would be minus 1 over x minus 1. Don't need to do the chain rule for each of these because it's just 1 times x here. Let's see, natural log of 3x minus 4 quantity to the cubed. I can rewrite this first. I'll rewrite it as with the exponent in front. Okay, and then now I'm going to take the derivative. When I take the derivative, I can just leave the 3 there, and then I take the derivative of natural log, which is 1 over the contents, and then I need to do a chain rule, multiply it times the derivative of the bottom, which would be 3. I can simplify that. It would become 9, 3x minus 4. Okay. This one here, I can rewrite this. It's the derivative of a quotient, so I could divide this into the natural log of the top minus the natural log of the bottom. Now I can do the derivative separately. 1 over x squared plus 2x, and this would be 1 over x minus 5. Subtract, right? See, I avoided doing the quotient rule by breaking it up into a difference. Number 5 looks like kind of a strange problem. It doesn't tell us to find the derivative, does it? Instead, it presents us with the function f, which has two undefined numbers here, a and b. And then it gives us clues here and here about what a and b might be. One of the clues tells us what the derivative would be if we plugged in e. And so the result is we need to find a and b. And in order to make use of this piece of information, we do need to take the derivative. So in the end, we do need to take the derivative. If we do take the derivative, remember we're going to treat a and b as if they were numbers, not as variables, because the only variable here is x, okay? So since a is just a number, we leave it out there as a coefficient. We're going to take the derivative of the outside function, which is natural log. We're going to leave the inside, which is 2x plus b, the same. Then we're going to multiply times the derivative of the inside, which would be just 2. And then we're done. So it would be 2a over 2x plus b is the derivative. And now we're going to use our two pieces of information. The first piece of information says is when x is equal to e, y is equal to 3. So we're going to put that into our original f of x function. So f of e is equal to a natural log of 2e plus b. That happens to be equal to 3. F dash of e, which is this, I'm going to put e in for x, is equal to 6 over e. So now we have two equations and two unknowns. They're not nice equations, but we should be able to figure out what a and b are based on this. So the first thing I'm going to do is I'm going to try to solve for either a or b. This is a 6, it's not b. It looks like it's pretty easy to solve for this a because it's all by itself pretty much already. So what if I did that? I'm gonna say a is equal to 3 natural log of 2e plus b. Then I'm gonna put this into this a and see if that helps me. So 2 times 3 natural log of 2e plus b all over 2e plus b. And let me simplify this fraction. I'm going to have 6 on top because 2 times 3 is 6. 2e plus b and natural log of 2e plus b are both in the denominator. And now I know that 2e plus b times natural log of 2e plus b is equal to e, right? Because the tops are equal, right? They're both 6. The bottoms should both be equal too. So I'm going to write that out here for a second. 2e plus b, natural log of 2e plus b is equal to e. I can put this as a power for using the exponent rule. Right? And now I can get rid of the natural log by taking both sides to the e. E to the this is equal to e to the that. So 2e plus b to the 2e plus b is equal to e to the e. So just to show you explicitly, the e and the natural log canceled out, right? Okay, now I have something to the something is equal to e to the e. I can say that the bases are equivalent and the exponents are equivalent because they're all the same, right? So my 2e plus b is actually equal to e. So b is equal to e to the minus 2e, which is equal to negative e. So b is equal to negative e. What's a equal to? A is equal to 3 over natural log of 2e plus b, but b is negative e. So that would be 3 over natural log of 1e, because 2e minus e is 1e. And natural log of e is 1, so a is 3. Okay. That was awful. Okay. Recall from the investigation or copy from page 379 the derivatives for sine and cosine. The derivative of sine is cosine. The derivative of cosine is negative sine. Use the chain rule to find the derivatives for these functions. The derivative of sine is cosine. So the outside function derivative first, and I leave the inside the same. Then I take the derivative of the inside. Then I'm done. What about if I have cosine with something inside? So the derivative of the outside is negative sine. The inside stays the same. And then we take the derivative of the inside and multiply it at the end. So it looks like that. Okay. 1a, find the derivative for sine of 2x. So the derivative of the outside function sine is cosine. We leave the inside the same. Then we need to multiply the whole thing times the derivative of the inside, which is 2. So 2 cosine 2x. Next one. So we have cosine 3x and negative sine x. So the derivative of cosine 3x is the derivative of the outside, negative sine. Inside stays the same. And then we take the derivative of the inside. It's 3. Derivative of sine is cosine. So let's rewrite this. Negative 3 sine of 3x minus cosine x. The derivative of the outside function is negative sine. We leave the inside the same. And then we multiply the whole thing times the derivative of the inside function, which would just be negative 2. 2 sine 3 minus 2x. And that is the end of this page.